Good morning. Today we are going to see the details of Smith chart. So what is the Smith chart? Smith chart is a graphical tool that is used to solve for several problems in antennas and transmission lines. Using this we can find out the impedance at a point on a transmission line, reflection coefficient away from the load, determine SWR, and to design matching networks. It was developed by Philip H. Smith. That's why this chart is called by the name of Smith. It gives a qualitative understanding of the problem before we actually plug in to get the quantitative numbers. Moreover, Smith chart is such a nice graphical tool for RF and microwave engineers. Even an engineer visualize most of the problems. Learning Smith chart will be very valuable for us when we require to pursue RF or microwave engineer. It is a simple chart, but normalized impedances are used in the chart, and also it is a normalized reflection coefficient plane. Normalized impedance means the impedance divided by the characteristic impedance of the line. Normalized impedance contains resistance and reactance values, and they are in normalized form. Therefore, any load can be normalized by the characteristic impedance of the transmission line. These normalized functions are plotted in reflection coefficient plane because the reflection coefficient will also be a complex. That is, the reflection coefficient is related to the load impedance and the characteristic impedance of the line. If the load impedance is complex, reflection coefficient is also complex. Therefore, they have the one-to-one relation between them. The Smith chart is a collection of circles. They are constant resistance circles and constant reactance circles. The radius and center of the circles are derived from the reflection coefficient and load impedance relations. Now, the resistance circles are drawn using the resistance circle equation, and thus the center and radius are varied with respect to the resistance value. Therefore, the completed circles are drawn in the Smith chart. Next, the reactance circles are drawn using different reactance values. The different reactance values gives the center and radius of the circles. The completed circles are called resistance circles. The incomplete circles are called reactance circles. The resistance value R equal to 0 at the left end of the Smith chart and R equal to infinity at the right end of the Smith chart. Similarly, the X value, reactance value 0 at the left side of the Smith chart, and the X values are varies from minus infinity to plus infinity. That is, upper hemisphere is called the positive reactance circle or inductive reactance circles. The lower hemisphere is called the negative reactance circle or capacitive reactance circles. Therefore, this is the overview of the complete structure of the Smith chart. That is, here we are having n circles. The completed circles are resistance circles. These are the positive reactance circles. These are the negative reactance circles. Now, the left end of the Smith chart, at the left end of the Smith chart, R equal to 0. That means the load is a short circuited one. At the right end of the Smith chart, resistance equal to infinity. That means the load is a open circuited load. Here we are having the reflection coefficient equal to one circle. This circle is called unit circle. At the center of the Smith chart, reflection coefficient equal to 0. So, the reflection coefficient value varies from 0 to 1, not greater than 1. Now we are having a reflection spot question. So, in the outline of the Smith chart, the normalized impedance 0 plus 1 corresponds to 0, A, B, C or D. Here we are having 3 questions. Then details of the Smith chart, that is, we know the resistance, reactance circles. Apart from this, here we are having 3 scaling circles, that is, outermost scaling circle is used to move towards the generator. The next circle is used to move towards the load. These 2 circles are scaled by the wavelength. The third innermost circle is in degrees. So this is the overview of our fundamentals of Smith chart. Thank you.